Hey everyone, welcome back to our podcast series on sustainable transportation. Today, we're delving into the world of electric vehicle production and exploring potential solutions for a more sustainable future. I'm Sean, your host for this podcast, and I'm happy to be here. I hope you are too. I'm a 2A mechanical engineering student, and I come to this issue as someone who's passionate about cars.
My name is Pranav, and I'm also a 2A mechanical engineering student. I'm passionate about developing sustainable technologies for the future.
My name's Dharmik, and like Pranav and Sean, I'm also a 2A mechanical engineering student. I developed a passion for the automotive industry during time I spent in an auto shop back in high school. The progress of the industry from gas to electric-driven vehicles is an interesting area of research that I was eager to pursue with this team of students.
Hi, my name's Connor, and yeah, you guessed it, I'm also a 2A mechanical engineering student. I'm passionate about the automotive industry and helping the environment.
Wow, not a lot of diversity here.
Well, yeah, maybe not in terms of program, but as far as what we bring to the table, I think our audience is going to see that we have a lot to offer.
Thanks, lads. Now, like I said before, this podcast is about sustainable transportation. So first, I think it's important to understand the 11th UN Sustainable Development Goal. Pranav, can you give the audience a little refresher?
Absolutely. Goal 11 is essentially all about making cities and communities more sustainable. That's where EVs come in. But there are some underlying problems lurking around that.
Thanks, Pranav, but underlying problems? What's that about? Connor, aren't EVs already clean and sustainable compared to internal combustion engines or ICE cars?
Yes and no. EVs are cleaner throughout their lifetime compared to ICEs, but as far as production goes, they're actually much dirtier. This comes from mining materials like lithium, cobalt, and nickel. Lithium is especially the main culprit. In fact, on average, EV production results in 17 metric tons of carbon dioxide emissions, which is double that of an ICE.
Those are big numbers. And Dharmik, what's the impact of this?
Well, the implications are definitely profound. Studies have shown that this contributes to climate change and a lot of ecological issues. Other issues include the absorption of carbon dioxide in the oceans, poor air quality, formation of ground-level ozone, and many others. It's a pretty big issue.
Wow, a big issue indeed. But there are some fixes in the works, like Li-Cycle here in Canada, tackling battery recycling, and car makers around the world looking for EV batteries that don't rely on those dirty minerals. However, these solutions have a lot of unaddressed gaps. Pranav, could you tell them about our plan?
This is where it gets juicy. Our solution to this problem is a social venture called Amped Up Rides. The idea is to buy old ICE cars nearing the end of their engine life and convert them to electric with sodium-ion powered batteries. These refurbished cars are then sold, and people can buy a cheaper used EV rather than a brand new EV. This helps offset the carbon footprint surrounding EV production. Sodium-ion batteries offer a promising alternative to traditional lithium-based batteries. Sodium, which is essentially salt, is found everywhere. Moreover, the mining of sodium-ion is much less resource-intensive compared to lithium and has a smaller carbon footprint.
Thanks, Pranav. Now, Connor, give us the market scoop.
For sure, people wanting to buy an EV often hesitate because it's so expensive these days. Our social venture targets this market segment, aiming to appeal a lower income bracket. Additionally, environmentally conscious individuals, especially from the Gen Z, Millennial, and Gen X demographics, are inclined towards more sustainable options. Dharmik, could you talk about the viability?
This business model has hefty operational costs, like salaries, rent, and equipment, but it stays afloat from the profits. The viability rests in cost-effective options for consumers and the cleaner life cycle offered by sodium-ion batteries, aligning with our sustainability goals. Pranav, can you talk about the feasibility?
It turns out that turning regular cars to electric isn't new. People have converted cars and even buses, such as Dean Knider, already. We've got the technology, and if there's a steady availability of sodium-ion batteries, we're good to go.
Thanks, guys. Now, to gain more industry knowledge about the topic, we chatted with the aforementioned Dean Knider. Here's a little bit about Dean. He's the founder and CEO of two Vancouver-based EV companies, Rise EV, and Green Ox. Rise EV retrofits classic gas-powered vehicles into electric ones, and Green Ox makes electrified airport tractors. Essentially, Dean is a whiz in EV conversions. Connor, what were your key takeaways from Dean's insights?
Well, Dean first talked about the government red tape surrounding EV conversions. Right now, there's an ongoing movement in Canada to switch all yellow school buses from gas to electric. Dean initially started Rise EV to convert yellow school buses to electric, instead of having companies build new ones. This is because Dean believes in a cyclical economy, and he wants to preserve existing assets instead of throwing them away. But we learned that in his pursuits, the federal government and the established big school bus companies like International, Greyhound, and Bluebird precluded him. That is when he switched Rise EV to converting yellow school buses to classic cars.
Dharmik, what were your insights?
Well, Dean told us that in Canada, new vehicles fall under federal oversight, whereas used ones are governed by individual provinces. Different regulations across provinces is an issue we'll need to address.
Okay, and Pranav, what did Dean have to say about our proposed solution?
Obviously, since Rise EV is very similar to amped up rides, he loved the idea. He wasn't familiar with sodium-ion batteries per se, but was open to the suggestion. But if he was going to adopt it, he said that he needed to ensure that it'd be safe, as he values safety above all else. This is a quality we all share.
Yep, safety is the top priority. I mean, that's why we're here, right? We want to make urban communities safer by making them more sustainable. Now, Connor, what did Dean say about his conversion time?
Well, Dean said he's aiming to streamline the process to under 2 weeks. If prepared beforehand, an ICE car can be converted to electric in even a day. But I digress. A timeline of 2 weeks is a similar timeline to our proposed business solution.
All right, then, we got to be aware of government regulations, ensure safety, and keep a conversion timeline of 2 weeks. Using all the insights from the interview, what other changes do we got to make to our business model?
Well, lowering the carbon footprint is the main goal. From his Green Ox Airport Tractor Company, Dean worked with Mohawk College to conduct a study to see how much reduction there would be of carbon emissions. In a similar way, our business model is going to have to conduct a comprehensive life cycle assessment of the conversion process. We'll need to know for sure if this business model will reduce the carbon footprint.
Dean also talked about some issues he's had with the battery supply chain and how that affected conversion time. Our business model must ensure a reliable supply chain for smooth sailing.
All right. Any other things, boys?
Yep, validating the technical feasibility of sodium-ion batteries is a must. Testing, prototyping, and collaborating with experts in automotive engineering and battery technology will help ensure their suitability and safety.
Right, well, that's all. We conclude today's episode on our quest for a greener future in electric vehicle production. We've unraveled the complexities surrounding the carbon footprint of EVs, explored existing solutions, and delved into the promising prospects of sodium-ion batteries.
Our interview with Dean shed light on the intricate web of regulations governing EV conversions and highlighted the challenges that our proposed business model would need to navigate to bring about a meaningful impact.
Contemplating the ramifications of curbing the carbon footprint in EV production, we're not merely addressing climate change, but also safeguarding our precious ecological systems and the quality of the air we breathe. It's a profound impact on the world around us.
Our proposed business solution, pivoting towards sodium-ion batteries, aligns with the ethos of sustainability and innovation. By welcoming and integrating new technologies, we're on the brink of revolutionizing the EV landscape, effectively mitigating the carbon footprint entrenched in traditional battery production.
The quest for sustainable transportation isn't a destination, it's an ongoing voyage. Challenges are part of the journey, but they're met head-on with innovative solutions and a collective commitment. We learned that from Dean and from ideating all together as a group. Together, these efforts pave the way for a cleaner, greener future. A future we're all excited to be a part of, and we hope that you're excited to be part of that future too. So, to all our listeners, Thank you for embarking on this exploration into the realm of electric vehicles with us. Stay tuned for more insights and exciting developments in our quest for a greener tomorrow. We hope to see you next time.
Bye, guys.
Alright, safe fam.
See ya.